in the last tutorial, binomial theorem for any positive integral index, we got the general terms of x plus y whole to the power n and x minus y whole to the power n. X plus y whole to the power n, here we got the general term ncr x to the power n minus r into y to the power r, and in the expansion of x minus y whole to the power n, we got the general term as minus y minus 1 whole power n into ncr x to the power n minus r into y to the power r. Friends, before we proceed to the next part of this tutorial, I request all of you, please subscribe the channel and press the bell icon for the future updates. Friends, my question is to you, what is the expansion of x plus y whole to the power 4, or what is the formula of x plus y whole to the power 4? Because you know the formula of x plus y whole cube or x plus y whole square, but you do not know the formula of x plus y whole to the power 4. For this, I shall show you the Pascal triangle and the formula, how to get the formula of x plus y whole to the power 4 or x plus y whole to the power 5, like this. So friends, first of all we write the indices, okay, index and their respective coefficients, okay. You know, the indices are started with 0, 1, 2, 3, 4 or 5 and many more. When the index is 0 of x plus y, then obviously the coefficient is 1. I have to show again the previous tutorial. Actually in this previous tutorial it was written, and watch carefully. Index is 0, coefficient is 1. Index is 1, coefficients are respectively 1 and 1, isn't it? So I write 1 and 1 for index 1. It is 1 and 1. Now index is 2, okay. That means x plus y whole square. X plus y whole square. The coefficients are respectively 1, 2, 1. So I write 1, 2 and 1. And index is 3. That means x plus y whole cubed. X plus y whole cube. The coefficients are respectively 1, 3, 3, 1. So I write 1, 3, 3, 1. Now you have to carefully observe the hierarchy of these coefficients. Here you observe a pattern is created. It is 1 plus 1 is equal to 2. Observe carefully. This is 1 plus 1 is equal to 2. 1 plus 2 is equal to 3. 2 plus 1 is equal to 3. So in this way, if I proceed to the index 4, then we shall obviously find 1. The first coefficient is 1. The last coefficient is 1. In this way, 1 plus 3 is equal to 4. 3 plus 3 is equal to 6. 3 plus 1 is equal to 4. That means 1, 4, 6, 4, 1 are the coefficients of the expansion of x plus y whole to the power 4. And obviously for the index 5, I have to write 1 and 1 on the last term, and the middle terms are respectively 1 plus 4 is equal to 5, 4 plus 6 is 10, 6 plus 4 is 10, and 4 plus 1 is equal to 5. So the coefficients of the index 5 are respectively 1, 5, 10, 10, 5, 1. So my question was, what is the formula of x plus y whole to the power 4? So write x plus y whole to the power 4. So friends, this is the index 4, and you have also index 4. So you know, in the last tutorial I told, whatever it is given, x plus y whole to the power 4, x plus y whole to the power 3, or x plus y whole to the power 5, whatever it may be, the first term will be x power the index given, that means x to the power 4, and the last term will be y to the power 4. I write y to the power 4. Okay. Now since this is positive and index is also positive rational index, so we should follow all the positive signs. So x to the power 4, next coefficient, the first coefficient is 1. It is written for 4. This is 1. Next coefficient is 4, so write 4, and x will be, the power of x will be 1 decrement, that is x cubed into y to the power 1. here in the first term y to the power 0, that means the index of y was 0, and here y to the power 1. Next coefficient is 6, so we write 6 x to the power 2 because it was earlier x cubed, so you have to take x square, and y to the power 2, y to the power 1, y to the power 2. Next coefficient is 4, so write 4x into y to the power 3. You observe carefully, x to the power 4, x to the power 3, x to the power 2, x to the power 1, and finally x to the power 0 here. So how many terms are created? 1, 2, 3, 4, 5. This is actually the expansion or the formula of x plus y whole to the power 4. X plus y whole to the power 4, the formula is x to the power 4 plus 4x cube y plus 6x square y square plus 4x y to the power 3 plus y to the power 4. Okay, there is no gap between. Friends, now I shall write the expansion of 1 plus x whole to the power n. Okay, so write it here, 1 plus x whole power n. Friends, you know the expansion of x plus y whole to the power n. In place of x we have written 1, and in place of y we have written x. So the expansion is very simple. You know the expansion of 1 x plus y whole to the power n. In this way, similar way you write the expansion. The first term will be obviously 1 to the power n, and the last term will be x to the power n. So write the first term 1, and similarly the other terms. So nc1, 1 to the power n minus 1, whatever you put the power of 1, it will be again 1. So we do not write the powers of 1. So only you should write the powers of x. So this is x, nc1x plus nc2x squared, nc3 x cubed, and so on. It is continuing. The last term will be obviously, I said, x to the power n. So the last term is x to the power n. This is the total expansion, but you have to write the r plus 1th term also. So the r plus 1th term will be ncr x to the power n minus r plus so on. So we write the general term. The general term of 1 plus x whole to the power n is tr plus 1, and tr plus 1 will give you this term. That means the general term is ncr x to the power n minus r into y to the power r. Okay, this is the general term of the expansion of 1 plus x whole to the power n. So if it is given that 1 minus x whole to the power n, earlier in the, that means in the last tutorial you got x minus y whole to the power n, the signs were alternate. It is plus minus and continuing. So in this expansion also it will be continued 1, since there is a negative sign in between. So this is 1 minus nc1x plus nc2x squared minus nc3x cubed plus so on. It is being continued, and the general term, in the general term also you do not know what will be the sign of this one. So for these we have to put a operator here. The operator is minus 1 to the power r into ncr x to the power n minus r. So what is the function of minus 1 to the power r? When r is even, then it will minus 1 to the power n even number will be positive, creates the positive sign, or minus 1 to the power odd number, it creates a negative sign. In this way the last term will be minus 1 to the power n into x to the power n. The concept is the same. So it is the general term. So you have to write the general term. This is the general term. So tr plus 1 is equal to minus 1 to the power r into ncr into x to the power n minus r. This is the general term of the expansion of 1 minus x whole power n. Friends, now we shall find the middle term in the expansion of x plus y whole to the power n. Okay, earlier we said that if the index is n, then in the expansion you will get n plus 1 terms. Okay, clear? When the index is n, then the expansion will get n plus 1 terms. As for example, x plus y whole square. Earlier I said this one, again I am repeating, x plus y whole square. This is x square plus 2xy plus y square. Okay, index is 2. How many terms are here? 1, 2 and 3. So 3 terms are here. If index is 2, 3 terms. If index is n, then the expansion will contain n plus 1 terms. Now we shall find the middle term in the expansion of x plus y whole to the power n. Before that, n may be an even number or n may be an odd number. So first of all, we take n is even. Okay, if n is even, then obviously n plus 1 is odd, isn't it? N plus 1 will be odd. That's the succeeding number. Okay, n plus 1 is the just succeeding number of an even number. This is odd. Okay, so if n plus 1 is odd, then obviously the middle term, there will be only one middle term. The midterm will be n by 2 plus 1th term. The middle term will be n by 2 plus 1th term. But how? You observe here again, I repeat, x plus y whole square. What is the index? Index is 2. Here n, x plus y whole to the power n, in place of n we have written 2. So n is equal to 2 here. Okay. So if you want to find the middle term, the formula creates here n by 2 plus 1. That means 2 by 2 plus 1. That means 1 plus 1. That is the second term. Second term. Is it? This is the second term, 2xy. So 2xy actually the middle term in the expansion of x plus y whole square. So if n is even, in general case, we can say that the middle term in the expansion of x plus y whole to the power n will be n by 2 plus 1th term. Next, if n is odd, so in this case, n plus 1 will be even, isn't it? So in even number of terms, from the even number of terms, you will get 2 middle terms. This is very important case. N plus 1 is even, so in this expansion you will find 2 middle terms. So the midterms are respectively n plus 1 divided by 12th term and n plus 1 divided by 2 plus 1, that's the succeeding term. And this term can also be written n plus 3 divided by 12th term. Just you take the LCM 2 and n plus 1 plus 2, that means n plus 3 divided by 12th term. So these are 2 terms in the middle of the expansion of x plus y whole to the power n when n is odd. Now you have to check this one. First of all, you take an example, say x plus y whole cube. Okay, x plus y whole cube. N is 3. 3 is an odd number. So in this expansion, you will get x cube plus 3x square y plus 3x y square plus y cubed, isn't it? So obviously you see these and that one are the middle terms. And how to get actually? So the rule is n plus 1 divided by 2. Here n is equal to 3, isn't it? N is equal to 3. So 3 plus 1 divided by 12th term. That is the second term, isn't it? This is the second term. This is the second term. And similarly n plus 3 divided by 2. N is 3. So 3 plus 3 divided by 2. That is equal to 6 by 2. 6 by 2 is equal to 3. That means third term. Yes, third term is also the middle term here. So second and third terms are the middle terms in the expansion of x plus y whole to the power 3, and 3 is an odd number. Okay, so formula created. The middle term in the expansion of x plus y whole to the power n, where n is an odd number, are respectively n plus 1 divided by 12th term and n plus 3 divided by 12th terms. Okay. And the last concept is x plus y whole to the power n. My question is, how many terms in the expansion of x plus y whole to the power n? There are n plus 1 terms in the expansion. Okay, n plus 1 terms in the expansion. Now my question is, what is the pth term from the end of the expansion of x plus y whole to the power n is equal to which term from the beginning? Okay, this is important. Pth term from the end is equal to which term from the beginning? Observe that x plus y whole to the power n gets n plus 1 terms in the expansion. Okay, 1, 2, 3, 4, 5, 6. In this way, this is n plus 1 term. Okay, so if you count from the end, this is given pth term from the end. So the ranking of this one will be 1, next 2. In this way, say this is the pth term. Okay, pth term. So since there are n plus 1 terms in the expansion of x plus y whole to the power n, isn't it? So you just write n plus 1. Okay, I have written n plus 1 terms. Total number of terms in this expansion of x plus y whole to the power n is n plus 1. If you subtract p, then what will happen? If you subtract p, then the term which actually you want to get, that is the ranking of this number from the beginning, it will also be dismissed from the system. That means pth term from the end will also be discarded from the system. So you have to again add 1 to get the number or to get the rank of this number, required number. So we have added again 1. So that means we have included the pth term from the last. Okay, so what will happen now? This is n minus p plus 2th term from the beginning. Okay, so again I repeat, x plus y whole to the power n gets the total number of terms in the expansion n plus 1, and the pth term from the end will be n minus p plus 2th term from the beginning. Thank you. Have a nice day.